Algebra II, 7.4a, FOIL with radical expressions. We've foiled with binomials before. Now they're going to have radicals in them. And if you haven't seen the previous videos for Chapter 7, and you feel like you're starting to get lost or confused, you need to go back into this video's description and click on those previous videos so that you can find out what you missed. An expression like 3 times the 5th root of 7 represents a single real number. It has all the properties of a real number, and it can be manipulated using the properties of algebra. Just treat it like a real number. Take a look at this. We've got the square root of 3, and we can distribute it into the parentheses and multiply it to each one of these other radicals. So that gives us the square root of 3 times the square root of 2, and the square root of 3 times the square root of 3. We can write it under one radical sign and get square root of 3 times 2, which is a 6. This is a 3 times 3, which is a 9. Square root of 9 is a 3. So it simplifies to the square root of 6 plus 3. And to multiply radical expressions in which some factors contain more than one term, we use the same procedures as we use for multiplying polynomials. We distribute, we FOIL. So we can multiply this one. We're going to distribute this cube root of y into the parentheses, and that's going to give us the cube root of y times the cube root of y squared. And we can combine these under one radical sign, and y times y squared is y to the third power, so we have the cube root of y cubed. And we do the cube root of y times the cube root of 2, and that just gives us the cube root of 2y. We can put the 2 in front of the y, in front of the variable. So now we've got the cube root of y cubed plus the cube root of 2y. Well, this is the perfect cube, so we can remove this radical sign and our root and just have a y times cube root of 2y. See? We can also FOIL. We can do the first, outer, inner, last, just like we did with binomials. This would give the square root of 2 times the square root of 2, which we can write under one radical sign, and that would be 2 squared, or a 4, and the square root of 4 is a 2, isn't it? And it's going to give us square root of 2 times a negative 1, which gives us a negative square root of 2, and a positive 1 times square root of 2, which gives us a positive square root of 2, and a positive 1 times a negative 1 gives us a negative 1. This negative square root of 2 and positive square root of 2 cancel out as additive inverses as a 0 pair. So the only thing we've got left is this square root of 2 squared, which is a 2, minus that 1. 2 minus 1 is a 1. We did all of that just to get a 1. See that? Okay. So let's try a little bit bigger FOIL. Take a look at this one. Hopefully my color coding will help you. We're going to do first 4 times the cube root of 3, or 4 times the square root of 3 times the square root of 3. We're going to do that right here. And we can write them under one radical sign as 3 times 3, which gives us 3 squared, which is a 9, and the square root of 9 is a 3, so that's 4 times 3. That's going to give us that 12 right here. Then we've got 4 times the square root of 3 times a negative 5 times square root of 2. That's right here. That's the outer. And we can multiply this 4 and that negative 5 together. And we can multiply this square root of 3 and this square root of 2 together. That's going to give us a negative 20 times the square root of 6. See? For the inner one, we're going to do square root of 2 times square root of 3. That's just going to give us a square root of 6. See? And for the last one, we're going to have square root of 2 times a negative 5 times square root of 2. Okay? So we can multiply this invisible 1 in front of this radical sign to that negative 5 and get a negative 5. And this square root of 2 times that square root of 2 ends up being the square root of 2 squared, which is a 4. And the square root of 4 is a 2. So we have negative 5 times 2. That's going to be this 10 down here. So what's going to happen is, because we have this negative 20 times square root of 6 and this positive square root of 6, there's an invisible 1 there. If we have a negative 20 and we're adding a 1, we're going to get a negative 19 square root of 6. And here's our negative 10. We can combine our like terms of the 12 and the negative 10. 12 take away 10 is a 2. So we have 2 minus 19 times the square root of 6. And we're treating this as if it's a single real number, okay? That's why we're not saying it's a negative 17, because we're treating this as a single real number. We'll just leave it like that, okay? We can multiply as the sum and differences of two expressions, sort of like the sum and difference of two squares, right? So we've got the square root of 5 plus the square root of 7 times the square root of 5 minus the square root of 7. See the plus and the minus? So it's a difference of the two expressions. And we can put this 5 times this square root of 5 under one symbol. And this positive square root of 5 times a negative square root of 7 is going to give us this negative right here. It would be a negative, it would be the square root of negative 35, wouldn't it? And then we do it again. Here's another 35, the 7 times 5, square root of 7 times 5. And then we have the last one. We have a positive 7 times a negative 7. Okay? So that's going to give us a negative 7 squared. So now we've got this square root of 5 squared minus the square root of 7 squared. That's gone because we canceled it out as a 0 pair. And all we've got left is a 5 minus a 7. Because it's a perfect square, that's a perfect square. We can take the radical signs off. 5 minus 7 is a negative 2 when we subtract. And we've got our answer. It's a negative 2. Now we can also do the square of a binomial. If we've got the square root of 7 minus 3 squared, we could open it up like this and FOIL it. Or we can use the formula for the square of a binomial. I don't know if you remember, but the formula was that x minus y squared, and then we can open it up into this trinomial. So we'll use the square root of 7 as x, and this negative 3 is y, and we just plug in the values from our binomial into the formula, and instead of getting x squared, we get the square root of 7 squared. Instead of getting minus 2xy, we get minus 2 square root of 7, 3, and they get multiplied together, right? And our y was the 3, so we're going to have 3 squared. That's going to be that 9. When we can combine all this and remove our radical sign, we get a 7, because that's a perfect square. This negative 2 and that 3 makes a negative 6 times 7 squared, plus the 9. We combine the 7 and the 9 to get a 16 minus 6 times 7 squared. See? So we just used the formula for the square of a binomial to solve this one. See? Just substitute the values in. So there's a lot to do, but it's easy multiplication, addition, and subtraction. So when you see this, it's not that hard to do. It's just, it's easy work. There's just a lot of it. So you just take each step a little bit at a time. And remember, if you see the square root of 5 squared, it's the same thing as the square root of 5 times 5. It's the same thing as the square root of 5 squared, and it's also equal to 25, isn't it? Square root of 25 is 5. Now our next video is going to be 7.4b, and we're going to talk about rationalizing the denominators of radicals. We rationalize the denominators in Algebra 1, but now we're going to have radicals in them, okay? I'm going to add this video to the Algebra 2 playlist so you can use it to study, and I'm going to have links in this video's description for the Algebra 1 videos that were pertinent to this, multiplying radicals and adding and subtracting radicals, 11.4, 11.6. I'm even going to put a link to our big review factoring video that was in here, and there's going to be a link to all the previous Chapter 7 videos that we've done so far for Chapter 7, okay? And hopefully I explained this well enough, and you guys are doing all right, and I'll see you next video, and we'll rationalize the denominators of radicals. Keep your chin up. I'm proud of you. Keep watching these videos. You're going to do fine. Bye.